This is the Adams Gulch area, a really scenic trail area just north of the ski resort, Sun Valley Ski Resort near Ketchum, Idaho, central Idaho. These are some of the big cliffs above Adams Gulch. We can kind of look down there into the shadows to where Adams Gulch itself is, and then tucked in the valley to the east is the town of Ketchum and Sun Valley. And we're going to spend some time with this video looking at this really unique set of rocks that blankets this part of east central Idaho, forms some really cool and scenic landscapes. It's known as the Challis Volcanics. It's a big collection and assemblage of really diverse volcanic rocks that were first named and described near the town of Challis, so that's where the name comes from. And these rocks all formed in the Eocene, so about 45 to 50 million years ago. We're going to start with the story of the Challis Volcanics, and then we're going to move on to looking at these rocks and what they can tell us in some detail. So to understand the story of the Challis Volcanics, we have to first start before that time, during the Cretaceous period. And the Cretaceous period in Western North America was a time of subduction. So one plate was diving beneath North America. I'm gonna come over here to a diagram that I have from my book, Geology Underfoot in Southern Idaho. So during the Cretaceous, we had a plate diving beneath the North American continent, subducting beneath the North American continent. And our best model of what was going on towards the end of the Cretaceous is the subduction angle of this plate was shallow. So it wasn't being pushed steeply underneath the continent, it was more shallow, which means that it provided more compression to the east in uplifted areas as far away as South Dakota. But as the Cretaceous came to an end and we rolled into the Eocene, what happened was this subducting plate actually started to steepen and actually started to roll back towards the west coast. And as this subducting plate moved westward, what that meant to the North American continent is it was actually extended. So the extension or the stretching caused by the rollback of this downgoing plate here actually thinned the Earth's crust. I should have drawn this with a little thinner crust here. And by thinning the Earth's crust, that actually initiated the generation of magmas. And so magmas started to form because the crust was being thinned and started erupting through faults and vents in that area. And that's what gave us this really fascinating part or chapter in Western North America's history known as the Eocene. It's actually a time period that's being researched in quite considerable detail because we see some really interesting Eocene rocks and relationships throughout Western North America at that time. But here in central Idaho, what we had was a whole collection of volcanoes of different types. Some volcanoes were erupting fluid, runny lava like basalt. Other volcanoes had magmas that were more explosive, more sticky, like dacite and rhyolite. And here at this location, we'll spend a little time looking at these rocks here. So as we look at these cliffs here, which are maybe a couple hundred feet or so in height, we can see there's really no layering in these rocks, that it's just a jumbled pile without any sort of layering within the rocks themselves. Furthermore, we can also see there's some really large pieces of rock here. There's actually one big chunk there that's maybe 2 or 3 meters in diameter. We kind of wheel around over here. There's some really large chunks of rock embedded in this overall volcanic deposit. And so what these large boulders in the rocks are telling us is that whatever process deposited this material had to involve a lot of energy. It takes a lot of energy to transport and move rocks of this size. As we look at these up close, we can see that the rocks have crystals in them. There's a nice big crystal there, feldspar. So we can see some of the crystalline nature of these rocks. They're exceptionally red here because they've been, the iron in them has been oxidized quite a bit, makes them quite hard and resistant. One interesting thing I found at this little outcrop is some of this greenish material here, bluish green material, I believe could actually be some copper mineralization. So perhaps some groundwater has circulated through these rocks, maybe even when they were still hot, and precipitated out some copper material. So we'll head up just a little bit closer to the base of this outcrop and maybe take a closer look at these and then come up with a story, sort of something that might explain this jumbled pile of material. If we actually look in between these boulders, which are very angular, so this definitely wasn't deposited by a river. Rivers would tend to round the faces and the surfaces of the rock considerably. But if we look in between the particles, we can see, hopefully you can see some of these little black crystals, some little shiny spots in the rock. These are all crystals that indicate a lot of this material is ash. And so possibly what this might involve then is either a pyroclastic eruption, a big explosive eruption, or possibly, and maybe more likely, a lot of times these explosive volcanoes can erupt, and then you can have water, sort of these volcanic mud flows mixing the material, and these are called lahars. So this may represent a lahar, a big slurry of recently deposited and erupted volcanic material transported by rivers and streams coming off the flanks of these ancient volcanoes. Or again, possibly this is a pyroclastic material. Typically with pyroclastic flows, you'd expect it to be mostly ash, and we see quite a bit of these large blocks in here. So I think I would tend to favor the lahar angle of the story here. But nonetheless, a really fascinating story of explosive volcanoes erupting well before the Snake River Plain volcanoes that came much later. And there's a butte just to the north of here, maybe not even a mile from here, called Griffith Butte. Maybe it's Griffin Butte, I can't remember. And studies show that that's the likely volcanic center of this material. So that's essentially the eruptive vent that this material came out of. So we would expect, being that close to the vent, for the material to, this eruption, to have really large particles in it this close to the vent. So again, a really fascinating story, and a rock type that covers a large portion of east central Idaho, from again the Sun Valley, Wood River Valley area, up into Stanley to some degree, and definitely eastward over into Challis. But all part of the story here in central Idaho of the very unique and scenic Challis Volcanics.